Okay, so we will get right into the material today. I believe you've worked with histograms in the past. We're just going to go over a brief summary about what they are and how to build a histogram, because we'll be using them as we continue our statistics unit in a couple weeks. What we're going to look at first, there we go. What is a histogram? Well, a histogram is a graph that shows the distribution is how something is spread out. The distribution. So a histogram is a graph that shows the distribution of one variable data. And this data can be either continuous or non-continuous. Continuous or non-continuous. Continuous data is data that can take on any value within a given range. So, for example, your height could be 5'5", or your height could be 5'6", but it could also be 5'5.5", or you could be even in between 5'5" and 5'5.5". There's always going to be a number in between the other numbers if your data is continuous, an option between the other two options. So you could also have your weight, or you could have the distance between two things. Distance between two things is a nice example to work with, because distance is designed, it has many different units, so that for continuous data specifically. If we're measuring the distance between Toronto and London, then we might measure that in kilometers. But if we're measuring the distance from you to me when we're inside the classroom, we'll use meters, or the distance between a couple letters, we might use millimeters. So depending on which one we're using, depending on what we're measuring, will tell us which kind of units to use, and it really shows. So you can have 2 kilometers between two objects, but you can also have 1.9 kilometers, or you can have something in between that, just depending on how you're measuring it. So distance, weight, and height are all examples of continuous data. Please try to come up with 2 or 3 more examples on your own here. Examples of non-continuous data, we have different scenarios where you can only have a fixed number of options within a given range. For example, if we look at the number of goals in the hockey game last night, in a hockey game. Sorry for the messy writing here. So the number of goals in a hockey game, you can have 3 goals in a game, you can have 5 goals in a game, but you cannot have 2.5 goals in a game. So often our examples of non-continuous data are examples where you're counting whole numbers, where you're counting something that you can only have a fixed number of them within a range. So the only examples of possible goals between, say, 0 and 5 would be 0, 1, 2, 3, 4, and 5. Like I said, you cannot have 2.5 goals. Another example would be the number of family members you have. So again, you can have 1 family member, you can have 3 family members, say, that you live with, but you cannot have 2.5 family members. Either someone is part of your family or they're not. Now, I would like you to try coming up with a few more. Actually, I'll give you one more here. If you look at shoe sizes, when you go to the store, you can buy a shoe that's size 8, or a shoe that's size 9, or a shoe that's size 6, or you can buy a shoe that's 6.5 or 8.5. But there's nothing in between those options. Sorry, in between, say, 8 and 8.5, because shoes go up by half a size. So that's an example of non-continuous data options. Please try and come up with, again, 2 or 3 on your own. Now we'll look at this example here to build our own histogram. And again, I think you've done something like this before. We'll see how it goes. So the question says, student marks from Mr. Strickland's math class are collected. There are 24 students in the class, and the individual marks are all listed here. So here we have a list of 24 different marks. Now we're going to create a tally chart first, and then a histogram using a bin width. So we'll go over what that means, of 10 marks. So a bin width means the size, or the range between each bin. So our first bin, for example, these are bin 1, bin 2, bin 3, etc. So each mark range here is a bin. So from 0 to 9, that's in one bin, is what we call a group of our data here. So we can see that if we count the number of possible marks within this range, it will be 10, and that's by design up here. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's in there are 10 different options. So we'll make our the rest of our ranges for the different bins right here. So between 10 and 19, 20 and 29, 30 and 39, 40 and 49, 50 and 59. And so we notice here that all of our bins, they are all the same size. But they won't all have the same number of data points within them. They won't all have the same number of information within. So 80 to 89 and 90 to 99. We don't have any marks that were exactly 100. If we did, then we would need an extra bin here for it. But we don't, so we're okay. Now we're going to go through all the individual marks and tally in which bin they fall. So for example, mark 61, that falls between 60 and 69. So we put a tally mark here and we cross off 61. We're going to do that for every single mark within this math class. So 86 falls between 80 and 89. That gets a tally and crossed off. 44 falls in between 40 and 49. So it gets a tally and crossed off. And we continue like this all the way through the marks, and we'll see how it ends up. And what this will do is it'll show us how the marks are arranged in a way that's not immediately obvious if we're just looking here at the raw data, at the raw numbers before we organize them. We also notice when we're completing these tallies down here, when we're completing the tallies down here, what we notice is that we're losing information. For every mark, for example, this 27, I'm going to put it between 20 and 29 because that's where it falls. But if I'm just looking at my tally chart down here, I don't know if it's 20 or 21 or 22 or 23 or anywhere. I don't know which one it is between 20 and 29. All I know is that it falls in there. Often, when you're organizing data, what you're doing is you're taking away a little bit of information so that you can see the patterns in it. Remember, when we're making tallies, every fifth one we put a horizontal cross in between our vertical tallies so we can group together our 5 tallies for easy counting later. 64, almost done here. And 84 falls between 80 and 89. So there we go. So now what we're going to do, now we see we have all of our mark ranges and we've tallied up every single mark of these 24 grades to put into the chart here. So now our frequency means the number of times something occurs. So how many times did one of the marks here fall between 0 and 9? 0. How many times did the marks there fall between 10 and 19? Well, if I check my tallies, 0. But we did have a mark between 20 and 29. So that's a 1. 0 here. We had 1 between 40 and 49. And then we had 3 between 50 and 59. We had 4 between 60 and 69. And here we can see the majority of our marks are within this range, which is what you would expect with a successful math class. Between most of these are passing grades here. And so they're all tallied up. We have our frequencies. What we're going to do is create the histogram here. So first of all, we notice our bins go along the x-axis. That's horizontally right here. So our first bin is between 0 and 10. Our next bin, 0 and 9. Our next bin is between 10 and 19. And then between, 20 and 29. So we can just make all of our bins like so. 60, 80, 90, and 100. So on our y-axis here, we list our possible frequencies. So I'm going to say 1, 2, 3, 4, 6, 7, and 8. So now I'm going to go from my frequencies and my mark range, and I'm going to plot that into our histogram. So there was 0, again, the frequency was 0 between 0 and 9. So that's a bin right along our axis. We had 0 between 10 and 19. And we had 1 in between 20 and 30, 20 and 29. So I'm going to draw that bin like so. And I had 0 between 30 and 40. But I had 1 between 40 and 50. So that gets the same size bin as before. And let's see, between 50 and 59 I had 3. So 1, 2, 3. And then I had 4 between 60 and 69. So again, we notice we're having most of our information falling here. Between 70 and 80, we had a whopping 8 grades. 80 and 89, we were back down to 5. And 90 and 99, we had 2. So we notice when we're looking at this completed histogram here, we notice the majority of our data is falling on the right-hand side. If we were to take a guess as to the approximate average for the class, I could do so using this here. I'm trying to find about the middle of our data. So if I go along, I know there's not much data over here. Probably our middle is somewhere between our low and mid 70s. So I might guess about 75 would be the approximate average. So that's how we build a histogram, and that should let you complete some of the homework and understand the future topics that we go over.